Hello Year 10. You should now have completed all of the lessons on the transformations, vectors, similarity and congruence topic. So this lesson is your revision lesson, and to do that you have been sent, or on class chart is the diagnostic homework. Right, the first page looks like this, and it does continue. Now this looks like an awful lot, and there is. However, this does cover all of the things that you will need to know. Okay. Now, the first part is to do with vectors, which is probably the last thing that you have just been working on. Right. So, question 1 tells you the vector AB. So, to get from A to B, you need to go along the vector 3, 2. Well, that means we go 3 to the right, because this number is positive, and 2 up. Okay. So, using the squares in your book, you can go 3 to the right. So if that's my starting point, I'll label that as A. Go along 1, 2, 3, up to 1, 2. That's the point B. Now it's really important that you join those with a straight line, and you include the arrow to tell you which direction you are going. If you put the arrow the wrong way or the opposite way, that would be incorrect, because that would be the vector starting at B, ending in A. So a fairly straightforward one to start off with. Question 2. So vector arithmetic. So you start off with a vector 2, 5, and you add the vector 3, 1. Well, that is the same as 2 plus 3 and 5 plus 1. So that gives you the vector 5, 6. Part B, I'm not going to show all of the working out, but you should have got 7, 3. Part C, 7, 4. D, 7, negative 1. The reason it's a 7 on the top is because 8 plus negative 1 is 7. Negative 3 plus 2 is negative 1. E, you should have got 0, 0. And F, you should have got 0, 1. Okay, question 3. So just before we move on, just to be clear, I'm not showing the working out just for convenience, because it's the same every single time. However, you would need to show this. Okay, question 3. So we now need to describe each of the translations as a column vector. So column vector means it's going to be how many we're going to go along on the top, and then how many we go up and down on the bottom. So from A to B, pick a point, and we need to find where that corresponding point ends up. So if I pick that point there, the corresponding point is that one. So 1, 2, 3. So I've gone right 3 and then up 1. So from A to B is right 3, up 1. That's not a column vector, so we would need to write it like that. Part B, from shape B to shape C, pick a point again, it doesn't matter which one. I'll pick this one this time. We're going to go 1, 2, actually we'll go the other way, so 1, 2 to the right, and then 1, 2, 3 up. So that's right 2, 3 up. So that's right 2, 3 up. If I had gone up first and then right 3, sorry, up 3 first and then right 2, I would get exactly the same answer. A to C, right, so I'm going to go 1, 2, 3, 4, 5 to the right, and 1, 2, 3, 4. You should get that. Okay, question 4 looks at rotations, and I've just copied the shapes onto my paper here. Now for this question you will need some tracing paper. Now if you don't have tracing paper you can actually use some baking paper if you have that. That's what I've got here. Okay, so it's a little bit darker but it will still actually work. So question 4a asks us to rotate, in other words turn, this shape 90 degrees clockwise. Now just a reminder, clockwise is that way, anti-clockwise is that way. Alright, so first thing you need to do, trace the shape. Doesn't have to be perfect. And trace your centre of rotation, that's what the little cross is. Now, little trick, I always put a little arrow. I can't quite see that. That tells me the upwards direction of where I've started. Now if I'm going 90 degrees clockwise, my arrow must end up in that direction. So put my pencil and I'm going to turn it 90 degrees until that arrow gets to the direction that I know it should be in. Now if you go over it like I have there, it won't go through to your paper. Now a little trick, what I do is if you go over it after you flip the paper over, the tracing paper over, it will now put pencil on this side. You'll also notice it goes through, so you will need to rub that bit out. So going back to this, pencil on the corner, I know the arrow must end up going that way, rotate it, rotate it, rotate it, and go over the shape, and now the shape will very faintly be there, and that's your final shape. So go back over it neatly. Please use a pencil for this. Okay, so there's your final answer for that one. B. So again, trace the shape. Go back over it. I forgot to do my centre. And again, little arrow. So this time we're going 180 degrees clockwise. So my arrow should end up downwards. Keep going, keep going, keep going. And it's downwards there. Go back over it. And you can just about see the shape there. There you go. Okay, part C. We're doing 90 degrees anti-clockwise this time. Notice that my centre of rotation is not actually on the edge of the shape, that's fine. Again, when you do that you might need to rub out where it just briefly goes through. 90 degrees anti-clockwise, so my arrow should end up going that way, the end. And there we go. That's my shape. Now when you are checking your answers, the best thing to do is work out the distance from where you start to each point. So count the squares to check your answer. So in other words, from the centre to this point, where the right angle is, should be 2 immediately down. If it's not, you've done something wrong. Okay, D is a little bit more interesting because the centre of rotation is in the middle of the shape. You can still do this. So 180 degrees anti-clockwise. Again, always trace your centre of rotation. Just going to click over it again. Okay, 180 degrees anti-clockwise, so the arrow will end up down over. Turn. Okay, and there we go. Now, on this one, you will notice that the new shape actually overlaps the original one. Or to be more technical, the image, which is the shape that you get at the end, overlaps the object. Okay. So that's how you would do question 4. Just move it up a little bit there so you can see it. Okay, question 5 asks us to enlarge this shape by a scale factor of 2. So in other words, it's going to get, each of the sides is going to get twice as long. And we're given 2 different centres. Now, there's a couple of different ways to do this, and I'm just going to do part A, but I'm going to do it in 2 different ways, and then I'll show the answer to B, but I won't go through it fully. So, the first method is by drawing lines. Now, our centre of enlargement is 1, 2 in each case, in part A. So, what we need to do, using the drawing lines method, is we need to draw a straight line from our centre of enlargement through each corner of the shape. Now, we notice, or if we notice, this length here is 2. Now, because we're enlarging by a scale factor of 2, that length there must now become 4. Now, if we look at where our lines are, if you notice this point here and this point here have a length of 4. Oh, the distance between them is 4. So that must be my base. And you will also notice that this length here is 3. So therefore, if I'm enlarging by a scale factor 2, this length must become 6. If you notice from this point here to this point here is 6. And now it becomes pretty obvious from where the lines cross. And also the fact that each length must be twice as long as it was before. So that is our new shape. Now, I personally think the next way that I'm going to do it is easier, but it does require you to have some sort of knowledge of vectors. So, okay, so I've just labelled my centre again. Now, just to make this a little bit easier, I'm just going to label each of my corners. So I've just labelled them A, B, C, D, E and F. You don't have to do that, but it just makes things easier. So, to get from the centre, I'm actually just going to call that O. So to get from O to A, we need to go along a vector 2 to the right, 1 up. It's 2 to the right, 1 up. Now, because we're enlarging by a scale factor of 2, that's what it was in the question, I need to multiply that by 2. In other words, that means I need to do 2 times 2, which is 4. 1 times 2, which is 2. So that means from here I need to go along 4, 1, 2, 3, 4, up to 1, 2. So my new A point goes to actually where the original E point was. Now that may seem quite complicated, but it does get quite a bit easier once you get the hang of it. So O to B, 2 along, 4 up. Multiply that by 2, you get 4, 8. 4 along, 2, 3, 4, 5, 6, 7, 8. So that's where the new B point is. From O to C, well, that would be the 3 to the right, 4 up. Double that gives you 6, 8. Along 6, up 8, takes you to there. O to D is 3 along 2 up. Now this may seem like more work, but actually it's a lot less confusing, I think. So O to E is 4, 2. Double it gives you 8, 4. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. And then O to F is 4 along 1 up, double that. 8, 2. So 8 along 2 up. Sorry, 2 up to there. And now we get the outline of our new shape. And you will notice that you actually get exactly the same answer. Now, it doesn't matter how you've done it, but that is the correct answer. Part B, I'm not going to do fully, but I am going to show you where the correct answer is. But basically, take your answer to part A, go along 1 and down 1. So part B, I'm going to do in red. You should get your final answer to be there. So the red one is the answer to part B. Alright, question 6 asks us to describe fully an enlargement. So in other words, you need to state that it is an enlargement, first of all, that or what the scale factor is, and also what the centre of enlargement is. Now again, there's a couple of different ways you could do this. Now, part A, strange as it might sound, you actually have to state that it is an enlargement. You have to say scale factor. Now, this we can work out really easily because the original shape has a base of 2 and the new shape has a base of 6, so the scale factor is 2 times 3 gives me 6, so therefore the scale factor is 3. In terms of the scale factor for part A, I think there's actually an error in the question because your centre, sorry, the centre of enlargement. Apologies. So the centre of enlargement for A, I think there's an error in the diagram because it will give you a coordinate that is not an integer. And I think this shape has been drawn incorrectly, so for the purposes of this, please don't do question 6a. However, the enlargement is a scale factor 3. Right, part B. Again, we must state as an enlargement. Now, if we look at the original shape, so shape A, that has a length of 2, and on the new shape that has a length of 4. So the scale factor is 4. Sorry, is 2. Because 2 times 2 gives you 4. Apologies. So each length has doubled. Now, to get the centre of enlargement, let's pick a point on the new shape. So let's say there. Now, how do I get from that point to the same corresponding point on the original shape? Well, in this one, I've gone left 2 and then up 2. Now, because I'm doing a scale factor 2, I need to do that and then do it again. So left 2, up 2, and then left 2, up 2. Now, I know this has gone off the diagram, but that could happen in an exam. So that would end up to negative 6, 6. So that point there would be negative 6, 6, and that would be my centre of enlargement. So my centre of enlargement is negative 6, 6. Now, if this was an exam question, you would get 1 mark for stating enlargement, you would get 1 mark for stating scale factor, and 1 mark for stating that the centre of enlargement was negative 6, 6. Part C, right, again the shape's got bigger, so it has to be an enlargement. Right, so let's look at the original shape. So this bottom part here is 3, on the new shape it is 6, so therefore the scale factor must be 2. In other words, I've had to double, multiply by 2 each length. Alright, now the centre. Let's do this point here. So I've had, you could do any point, but I'm just picking a slightly more difficult one. So to get from this point to the corresponding point on the original shape, I'd have to go down 1, 2, 3 and left 1. Now because I'm doing it scale factor 2, I have to do that twice. So 1, 2, down 3, left 1, down 3, left 1. So that point there is my centre of enlargement, which is 1, 1. Now it can be a point on an original shape or on the new shape, it doesn't matter. So just because you get it there, that's absolutely fine. So the centre of enlargement is 1. Question 7. So we are looking at similarity and congruence now. So similarity links to enlargement because 2 shapes are similar if one is an enlargement of the other. 2 shapes are congruent if they are identical. So here's a load of rectangles. Part A, find the shapes which are similar to A. Well, in other words, it has 4 along and 2 up, or it's 4 by 2. So as long as the dimensions are any multiples of 4 and any multiples of 2, so in other words, if we look at C, I've doubled the 2 to get 4, double the 4 to get 8. In other words, the enlargement, even though it's been rotated, the enlargement from A to C is 2. And if we also look at D, I've halved each of the lengths. Instead of being 4, it's now 2. Instead of being 2, it's now 1. So C and D are enlargements of A. All the shapes similar to H, in other words, H is a 3 by 3 square, so any square. So that means B and F. Similar shapes to E. So E is 3 by 9. So if we look at I, it's actually a little bit more complicated, this one, because that is 4 by 12. Now it doesn't immediately look like it is, or it's not immediately obvious what the scale factor is, but actually if you divide both sides by 3, that gives you 1, 3, and then times them by 4, you get 4, 12. So I and J, well, J is 2, 6. Now again, if you divide that by 3 and that by 3, you get 1 and 3. Double them, you get 2 and 6. So I and J. Are any of the shapes congruent? And explain your answer. Okay, well the answer is no. And the reason for that is because there aren't two or more rectangles that are identical to each other. So a shape that is congruent to shape J. Okay, well shape J is 2 by 6. So any shape that has a dimension 6 and 2, it can be rotated. So that shape is congruent. But it has to be 6 by 2. Okay, question 8 asks you to find the missing sides in two similar triangles. Now, the way that I'm going to show you this is the formal method of doing this, because it's not easy to work out immediately what the scale factor is between the two. We don't know that. We can work it out, but we don't know it. Now, we know that if two shapes are similar, then one is an enlargement of the other, but also that the ratio of the corresponding sides are always equal. Now, what I mean by that is, first of all, I'll just label my two shapes. Now, what I mean by that is the length of this multiplied by the scale factor will give us the side length here, and the length of this multiplied by the same scale factor will give you 10, and the length of this side multiplied by the same scale factor will give you the 11.5 length du. So we know that the length AC and DF, because they are corresponding sides, must be equal to BC, this one here, must be equal to the ratio of that and EF, which must be equal to AB over DE. Now let's work out x first. So, because we want this side, that means we also need this side. So we're going to use this one here, and we have to use BC and EF, so this one here, because that's the only one that has both sides. It's the only pair of sides that we can use to work out the scale factor. Well, AC we know is 7.2, DF is x, that is equal to BC, which is 14, over 10. So the scale factor is actually 1.4. So the scale factor is actually 14 over 10, which is 1.4. So actually what you could do is divide 7.2 by 1.4, but let's do things properly. So what I can do is I can multiply by x on both sides. That's 7.2 is equal to 14 over 10x, or multiplied by x. And then I'm going to divide by 14 over 10. On both sides. So 7.2 divided by 14 over 10 will give you the side length of x. Now you can use a calculator for this, even though it doesn't say, by all means use a calculator. 7.2 divided by 14 over 10 gives you 5.14. So x, the side length x is 5.14 centimetres. Y will actually be slightly easier. So calculating y. This is actually a grade 5 topic as well. So this is about as hard as it can possibly get on the foundation paper. Okay, calculating y. So I have to use A, B and D, E, because that's the one that I want to calculate. So A, B over D, E. And again, I have to use BC and EF, because that's the only one that I know both sides. Okay, AB is Y, DE is 11.5, BC is 14, EF is 10. So I'm going to multiply both sides by 11.5. Y is 14 over 10 multiplied by 11.5. So therefore Y is 16.1 centimetres. Now, let's use a little bit of common sense. This triangle here is smaller than this one. So x had to be smaller than 7.2, which it is, which means it's probably right. And y had to be bigger than 11.5, which it is. So that was question 8. Question 9. So the vector q is given by the column vector -2, 4. So 2 to the left, 4 up. Write as a column vector a vector that in the same direction as q but twice as long. Okay, so for part A, If it's twice as long, we actually want 2 lots of Q. Now, hopefully you should have picked this up from the lessons, but because I can't write in bold, I underline a vector. In type, a vector is always given in bold. When I write it, I underline. So that's 2 lots of Q, which is 2 lots of negative 2, 4, which is negative 4, 8. Part B, a vector the same length as Q but in the opposite direction. Well, in the opposite direction, so this one here was 2 left, 4 up. So instead of 2 left, we need to go 2 right and 4 down. In other words, completely the opposite to this. Well, 2 to the right would be 2 and 4 down would be negative 4. Notice I've actually just multiplied the vector by negative 1. C, a vector 3 times longer than Q but in the opposite direction. Well, 3 times longer than Q will be 3 lots of Q, which is 3 lots of negative 2, 4, which is negative 6, 12. But that's still going in the same direction. So just like I did here, compare these two, I need to multiply both components by negative 1. So in the opposite direction, that's going to be 6, negative 12. Part D, a vector parallel but half as long. Now parallel, any vector is parallel if they are multiples of the original vector. So for instance, if I multiplied all of these by, or this by 2, so that could be negative 4, 8. I could multiply it by 3, so that gives you negative 6, 12. Could times it by 4, negative 8, 16. Those 3 vectors are all parallel, and so on. If it's half as long, that means the number that I need to multiply this by is a half. So I actually want a half of Q, which is 1/2 of negative 2, 4, which is negative 1, 2. Okay, question 10. This asks us to combine different transformations. In other words, do one transformation and then do another one from that new shape. So I'm going to start at shape A. It says copy it into your book. You don't have to if you printed this out, if you can print this out. So rotate the shape 180 degrees about the origin. The origin is 0, 0. So again, trace the shape slightly more accurately than I am. Include the centre of rotation, do the little trick, flip it over, go back over it, draw your north arrow. So 180 degrees clockwise or anti-clockwise mean exactly the same thing. Because if we think about it, if I went 180 degrees clockwise, I would end up with the arrow pointing down. Hopefully you can just about see that. Or if I went back to my original and went anti-clockwise, you end up in exactly the same place. So it doesn't actually make any difference when it's 180 degrees. Right, so go back over the shape. Won't be perfect, so go back over. And it says label the image, in other words, the shape that you get, B. It is possible in an exam, if you did not label it, you would get that marked wrong. Okay, reflect shape B in the x-axis. That is your x-axis. Right. So shape B, I'm actually just going to use the same bit of paper or the same shape that I had before. This time I'm going to include the x-axis on there. And I'm going to flip it over and match up my x-axis. I'm also going to match up, sorry, I should have also said, let's pick a point. So let's go with that one. So if we notice, I've got one to the x-axis down. That means I need to go another one down to where that new point will be. Go back over it. Now the other way you could have done this, like I said, is to count. So there's one down to the mirror line, so therefore there's another one to the new shape. One down to the mirror line, so therefore do it again. 3 down to the mirror line, so then another 3 there. And that gives you that point there. Label the image C. Describe fully the single transformation that maps shape A onto shape C. So from this shape to this shape. This is the most important, well, 2 most important words. Single transformation. That means there is only one. It's either a rotation, a reflection, an enlargement, or a translation. There's another one. And you have to describe it fully. So that means you must state which one of those transformations it is. Now hopefully you can spot straight away that this is a reflection. Because it's a reflection, you must state the equation of the line that it is reflected in, or the axis, if it is an axis. In this case it is an axis, it's the y-axis. So this is a reflection in the y-axis. Finally, we're nearly there. So, 2 similar shapes. In other words, one is an enlargement to the other. Find the scale factor of the enlargement that maps A to B. Okay, well let's think about our corresponding sides. AB and DE are corresponding. They are parallel. They've got the little arrows on. So, that side there and that side there are corresponding. This side here and this side here are also corresponding. Which means this side here and this side here are also corresponding. Now that also tells me, we think as well, these 2 lines are parallel, and therefore by angles in parallel lines, these 2 are alternate, which again tells me why that line and that line must be corresponding to each other, and that one are corresponding to each other. So, finding the scale factor, I'm just going to write it under here. The scale factor, so that means that maps A onto B. So that maps, it's not a very clear question actually. We'll say maps this triangle onto this triangle. So therefore, DE divided by AB, that is 6 over 15, which is 2/5. Now, because it's an unclear question actually, you could have done it the other way around. So if you did AB over DE, that would give you 15 over 6 which is 5 over 2, which is 2.5. Because it's a little bit unclear, either of those would be fine. Alright, part B, find the length of CD. So in other words, we're looking at this length here. So let's call that length x, and we're going to do something very similar to before. So I have to use A, B and D, E. I'm going to do it, I'll do it under here, so I'm going to use A, B over D, E must be equal to BC over CD. Now be really careful again, probably should have mentioned this earlier on when we were doing the other similarity questions. Make sure that these two are from the same triangle and these two are from the same triangle. If you put AB over DE equals CD over BC, that will not be correct. You will get the wrong answer. These two must be from the same triangle, and these two must be from the same triangle. So AB was 15, DE was 6, BC was 10, CD was X. I'm going to multiply by X. Looks complicated, but it's just a two-step equation. So 15 over 6 times X is 10. Don't try and work any of that out. I'm now going to divide by 15 over 6. So X is 10 divided by 15 over 6. So that gives you X is 4 centimeters. X is 4 centimeters. So therefore CD is 4 centimeters. Probably should write it like that. There you go. So I know that was a really long video. You don't have to watch it all. However, I hope that has been useful. And what I will leave you with is the overall answers. So there's the answers to the first 7 questions, and there's the answers to 8, 9, 10 and 11. Hope that's been useful, and good luck for your test next lesson.